And whenever the declaration or the function definition will occur for the first time, I mean during the compilation process, when the compiler will detect the first occurrence of a function, either declaration or definition, because function call will come after at least the declaration or definition. So whenever the compiler will see the declaration or definition of the function, then it will make an entry corresponding to that function into the symbol table, and corresponding to that function, it will create one symbol table. That you remember from the class of symbol table, where extensively we discussed that corresponding to each function, there will be a symbol table. Of course, corresponding to each a symbol table, so that is different. But now, corresponding to each function, there will be a symbol table, and also the information regarding the function will be entered in the symbol table. And if, say, I do not look at the grammar for the time being, and let us assume that I encounter this function declaration first, then what kind of modification? So first, well, I am assuming that this function declaration is outside of any function. So the scope of this function is global. If it is inside some function, then its scope is within that function. But if it is outside of any function, it's global. Therefore, the information regarding will be entered to the global symbol table, and that is this one. What is the entry? Please note it down that although there is only one entry in this global symbol table, but hardly that is the situation. There are some other entries, but since we are only discussing this part, that's why we are showing you this only one entry. So the entry indicates that what is this? That is the function. If you can see, this function is the name. So the identifier or name of the function is basically func that I stored as the name in my symbol table. Next, what is the type? Comparing with the variable type, usually it comes as the, say, parameter or say local variable, but in this case, it will come as the function type. Okay. Then one attribute is inserted here extra, that is the initial value. So as of now, we didn't discuss about this initial value, but if I assume then for this function there is no initial value, so it is null. Also, function doesn't require any space, that is why the size is 0, and offset will remain same. The dot 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 indicates previously what was the offset. The same offset will be maintained because offset indicates offset equals to offset plus size, and since size is 0, so offset will remain same. Next, one attribute or column I am inserting, that is the nested table. So this is the pointer to the symbol table corresponding to this particular entry. I am telling entry. Now you know that if this entry is a function, then corresponding to that function, there will be a symbol table. If this entry is a variable, then corresponding to that variable, there is no requirement of nested table, so it will be null. And if this entry, say, indicates some sort of block inside some function, you can give some name for that particular block. Well, in that case, the symbol table may not be global, it will be some other function name. Then corresponding to that, what is the symbol table? That pointer will be stored here. Okay. Next, here I am storing the pointer to the st, that is my symbol table with the name function. Next, I will create one symbol table st func. Now, as per this declaration, what I can see that there are two parameters, integer I and double D, and the return type of the function is int. So three entries I, D, and so this type also although here it is mentioned as the data type int double int, in our previous examples we used to maintain the type is parameter variable type. Initial value is null and size is as per my type definition. If it is integer, then 4. If it is double, then 8. Return value if it is integer 4. Accordingly, offset is also updated. Okay. So that is the symbol table. So what are the list of actions when I see the declaration or definition of a function? So corresponding to that function, I will make an entry to the global symbol table. Of course, I am assuming all the function declaration and definitions are outside of any function, so the scope is global. And that is the reason why I am making an entry in the global symbol table. Okay. Now, corresponding to each function, there will be a new symbol table which will contain all the information regarding that function. So if it is declaration of the function, then I will get the information regarding the data type of the parameters, how many parameters are there, and the return data type. But if it is definition, then along with that one, I will have local variable information and compiler generated temporaries when that will be generated during 3 address code generation. Now it is just a function declaration. That's why I have 3 entries id underscore readval. But when the definition will start, then that extra local variable information will be inserted. And when that function will be converted to 3 address code, then if required, and temporary variables can be generated by the compiler, then corresponding to that there will be entry to this function symbol table. Okay. Now for this purpose, I am now defining the grammar rule as well as the action corresponding to that. So D derives TID F opt. This F opt that you can understand. So parameter may be there, may not be there. So second production rule indicates that when parameters are there, so you need to create one symbol table corresponding to that. Third production rule indicates that it is epsilon, and then also you have to create one symbol table. So basically you can consider that you keep on expanding by second production rule, and when you will use the third production rule, then actually the symbol table will be created. The fourth production rule indicates that when you will have one type ID and F1, then you insert that symbol table information here. Okay. And when it is simple one, function derives type ID. The ID indicates the name of the function, and T is my type. Then I create one symbol table f.st, and then in that symbol table I insert my ID, what is its type, and the size is 0. The type T as of now is again the basic data type int double void, but definitely you can keep on incrementing that one. Although here I have mentioned T dot type is int double and void, and I didn't mention the with part, but you can also include that with information along with this int double void. Then you can store for int it will be 4, for double it will be 8, for void it will be 0, something like that. So here is the same example, int fun integer I comma double d two excuse me, two arguments, integer and double, and return type is integer. Now if I look at the symbol table, the simplest and easiest one, corresponding to this identifier or name of the function, there is an entry here. Now in the type, so I am writing int cross double arrow int, that is my type. Okay, size is 0, offset is accordingly set, and nested table I am giving the name stfung, that will store the address of the symbol table corresponding to the function fun, and it is here. Now the same entry id return value here, integer double integer 484, which was there previous. If I draw the parts tree following the grammar rule that I shown you previously on the last slide, then I will get int id is the name of the id is basically fun. Then within parentheses f opt, that derives to f1. Then f1 is going to f2 comma t3 idd. Then f2 is going to t2 int id I double. Okay, this is following, I'm going to the previous slide, following this grammar rule. Okay, so the grammar rule is mentioned here. Using this grammar rule, I have drawn this syntax tree first. Now if I look at the type assignment, well, I am not considering the with for the timing, but yes, with is also there. If you want, you can carry that attribute also along with this. Then t1.type is assigned to int, it comes first. Then t2.type is int, it is coming from here. Then f2.st equals to st function is coming. So from here it is coming. Then t3.type is double, t3.type is double, it is coming here. Then f1.st, from here it goes to f1, that symbol table information, and from here it is going to st fun, this one. Okay, so here more grammar rules when I am returning. So when I am returning the value, so third production rule you see, then I need to check if the function dot type matches with e dot type. That you remember that each function has a return type. Say I am writing say int main, and in the return type I forget to mention anything. Then you will get an error, an warning, not an error, that function main is supposed to return integer, but it is not returning anything. And say if you write void main and finally you return 0, then also it will say that it is supposed to return void, but you are returning something which is integer. So it is matching the type. So the type matching will take place here. Okay. Now when it is EID optional, then it will look up in a symbol table for the existence of this identifier. As you know that whenever I am going to make an entry to the symbol table, first I need to check whether there is an entry already in the symbol table or not. That's why probably instead of having insert into the symbol table, it's always a good idea to have one function lookup. That lookup will look for the existence of the identifier, either say name of the variable or name of the function, and then if it finds that one, then it will return the address. If it doesn't find that one, then it will insert that in that symbol table. Okay, so similar to that, here are the other production rules here. Okay, now for this particular example, integer a b c double d e a equals to func b plus c comma d multiplied with e return a. You remember sometimes you used to call the function, instead of the parameter you pass some arithmetic expression. So when you pass that one, then what happens is like this. So b plus c is added and stored in some variable t1. It is the compiler generated temporary. D will be multiplied with E and will be stored in another compiler generated temporary T2. Then I declare parameter T1, parameter T2, and I will call function by mentioning there are two parameters too. So these are the three address codes I'm writing in that. The value will be returned and stored as T3, then A equals to T3. You can basically merge these last two three address code and have only one three address code, like A equals to call func comma 2. That is also fine. Okay. Next, we are looking for the parse tree corresponding to this particular declaration. Okay. Now, three address code was discussed on the last slide. It is very simple. It is given here. Okay. Now, if I look at the symbol table, then what will be entered there? So here, although it is not mentioned explicitly, but in the ST global, so first it will be entered A, B, C, D, E, those variables. Okay. Because I am assuming that this is outside global. But if I do not assume, if I assume, okay, this is inside some function, then these variables will be in the symbol table corresponding to that function. That's why here you see that ST question mark. ST question mark indicates that Do you able to see my presentation now?
Yes, sir.
Sorry, there was a power failure and I was disconnected. Okay, so we are continuing in this slide. So here, okay. Now regarding this symbol table and parts tree, we discussed. Now let us look at this region. So the type assignment from this parts tree, how it is going. For that, you have to look at this tree structure. Now E3.lock, so this B, variable B. So in the 3 address code, B plus C equals to T1. Clearly, you can see this is an expression. So E3.lock equals to B is here, and E3.type is integer. Then E4.lock is C, and E4.lock is integer. Now you remember that while we are adding, we incorporated the type checking, that whether we are adding two same type variables or not. Since E3.type equals to E4.type, so we can add them B and C, and we can store that to some compiler generated temporary T1. So after the addition, this E2.log will be my T1. And E2.type will be int, because E3.type and E4.type both are of integer type. That T1 will be in A2.list here. A2.list actually is having the list of parameters. Now E6 block is D. Similarly, this D multiplied with E will be stored in E5, and since D and E both are of double data type, so E5 dot type will be double, and T2 will be stored in E5 dot log. So my E1 dot list is T1 here. So from A2 I am getting T1, and from E5 I am getting T2. So T1 and T2 is my E1 dot list, and that is also a opt dot list T1 and T2. That information or those two are considered as in E1 dot log. Sorry, it is considered in, and this E1 dot log will have the return value from this function. Okay, so U1.log equals to T3 and U1.type equals to integer. So this integer is the data type for the function. This integer is here. Okay, this double is here, and this integer is here. Okay. Now the lexical scope management, combining all the production rules that we have discussed as of now, along with some new production rules, so which are say up to 6 here. So PGM equals to TU update offset for the symbol table global, end of 3 address code translation. TU equals to TU1P, TU equals to MP. M is epsilon production, so this will create the global symbol table, and st global dot parent is 0. Nobody is the global, nobody is the parent of global. CST is st global. P derives VD. VD indicates variable declaration. P derives PD. PD indicates function prototype declaration, and P derives FD. FD indicates function definition. Now this PD, function prototype declaration, is kind of optional. It may or may not be there in your program depending upon whether function is defined before its use or not. Of course, sometimes some programmer has some affinity, or they love to declare the prototype irrespective of where the function will be defined. That way, it will be also safe in the sense that it doesn't matter where you will define. So prototype is declared means during the compilation, there will be no problem. After that one, so this array declaration, type declaration, those things we have discussed in detail. Function declaration, we just declared, then list of statement, variable declarations, and this these expressions, all those things we have discussed. Next few examples. Okay. So the first example is simple one. It contains one main function and one function for the addition. There are global variables and function prototype declaration is also there. And now probably you can feel that it is more like a C program. As of now, it was bits and pieces. Separately, we are discussing about the type expression, about the arrays, about the functions, about the blocks. Now everything is here, and using the list of the grammar rules, although I went over that one, and you can see using those grammar rules, actually you can generate the IR. So for this is the m derives to epsilon. Will create the global symbol table, and it will also make that there is no parent. This is the PD function projection. Then again it is the VD declarations. Two variable declared there. Next, FD function definition. There are two functions. That's why it is FD1, FD underscore 1 and FD underscore 2. Okay. So the zero production rule, if I go back, my PGM derives TU, this one. Okay. Now moving forward. So PGM to TU, then TU derives in left recursion TU and T5, then TU is going definition, function definition 1 and 2, variable declaration 1 and 2, and the function prototype definition. Of course, M derives epsilon, that is epsilon production, for creating the global symbol table. It is here. Okay. Now, following the similar logic that we have discussed so far in the context of several production rules and its actions, you can create the symbol table, you can generate the tree address code, and you can also determine the type expressions. Okay. So for this example, int x array 2, 3, and y, it is discussed here. So similar to this, several examples are given. So I am not going to discuss all those. So the slides will be uploaded. You please go through this. If you have any question or confusion in any one of the examples, so don't hesitate to contact. Okay. So this is the function we started with, and this is the tree address code. This is the symbol table. Since there are two functions, so corresponding to add there will be symbol table, corresponding to main there will be symbol table, and there will be a global symbol table. So in the global symbol table, the entry is X, AR for the array, then Y, then this add is for the function, then A, B, and main is for the function. For add, X and Y are two variables. T is compiler generated temporary, T has. Okay, for st main, so C has T has 1, T has 2 are the compiler generated temporaries. Okay, so this has is used because you know that for add in the local variable I use T. So just to avoid the confusion, has is used. Okay, so you can use say underscore T or something like that. So a valid identifier, and assume that that kind of identifier will not occur as a local variable in the program. Okay, otherwise you'll be confused with the whether it's a local or say compiler generated temporaries. Definitely, I know that you are entering that information in the symbol table. Still, to avoid the collision, or say if in one table you have 2T or 2T1, then definitely there will be a confusion. So just to avoid that one, it's better to use something which you will assume that programmer will not give as the variable. Okay, so these examples are there. You can basically look at this, and if you have any question, you can let me know. Okay, so up to this, do you have any question? Then let us stop this here and move on to assignment 5. Okay, so do you able to see assignment 5? The PDF I am sharing now. Last time it was a confusion, so I am sharing here now. Do you able to see this?
Yes, sir.
Okay, thank you. So this is the 5th assignment, and after this there will be one more assignment that will come say probably on 3rd week of October on 21st. As you can see, the deadline is too long, that is October 20. Okay, so initially that gives a good impression that okay, we have plenty of time, but actually it is not. So it is the case for assignment 5 for every year, because assignment 5 released and then mid-sem used to come. Now it is not mid-sem, but next week you have a test, and after that there is a DP. So combining those, you may not get much time, although it indicates that 3 weeks time is given to you. So assigned date is today. Right after that class, I will open it in the Moodle, and deadline is 20th of October. Again, this is a group assignment. The same group will be working on this one. And as I mentioned in assignment 5, also I will tell at the end of this assignment, while implementing this assignment 5, if you you need to use your own assignment 3 and 4. But if you feel that some grammar rule or some say scanning rule you need to change in order to accommodate some of the features that is expected in this assignment 5, so don't hesitate to go don't hesitate to do that one. You go ahead and do that. Okay, now the lexical grammar and phrase structure grammar, your assignment 3 and 4 for tiny c have already been defined by you. Okay, and this standard you are following. I also will upload one supporting file for this standard later, but as of now this file is enough for you. Now in this assignment you will write the semantic actions in Bison to translate a tiny C program into an array of 3 address quads, a supporting symbol table, and other auxiliary data structures. The translation should be machine independent, yet it has to carry enough information so that you can later target it to a specific architecture, either it is x86, IA32, or x86 64-bit system. Now regarding the second paragraph, so for the last probably 3 weeks, we extensively discussed the 3 address quads, symbol tables, auxiliary data structures which are required for us, and the Bison implementation. The same thing you have to do here, but as you know, because of the time constraint in the class, we were restricted within few rules, but while you are going for tiny C, the number of rules will increase. That is one thing. So it is not the new thing, the same thing that is discussed in the class you need to implement now, but few more, the production rule or semantic actions will come and you have to do that one. Also, you remember that say up to this module 5, we didn't talk anything regarding the machine, the architecture. So all our analysis, all our discussions are machine independent. So although it is mentioned that it is, the translation should be machine independent, but if you follow the class, then it is actually machine independent. And only information which might be machine dependent is kind of say, what is the width of integer, what is the width of double. That thing you also learn that how to make it a variable one. So in the production rule, you just mentioned that the width for integer is 4 or 2. So that flexibility is already there in our discussion, and in assignment 5 also you are going to that one. Because in assignment 6, when you will implement or target for some architecture, then the modification you need to do is make it hard code for that particular architecture. Okay. So scope of machine independent translation, focus on the following from the different phases to write actions for translation. Expression phase that we discussed, support all arithmetic, shift, relational, bit, logical, and assignment expression, excluding size of operator, comma operator, compound assignment operators. Support only simple assignment equals to structure component expressions. So among these, arithmetic, relational, logical, we already discussed, and also assignment expressions. This shift and bit you need to extend, although we used sometimes size of, but that is not required for our purpose. And this comma operator and this compound assignment, you know that we are familiar to use that one. It is not required for the time being. In the declaration phase, the support will be given for simple variable, pointer, array, function declaration should be supported. For example, the following would be translated. So float d equals to 2.3, int I w10, int a equals to 4, star p, b, void, func, character c. So you see, most of them is already discussed. These are discussed, this part are discussed, these are discussed. Character we didn't mention explicitly, or float, but you know that it is not a big deal. When you can mention integer, then you can mention float also, character also. Only thing is that in the type t derives int, you have to make a new production rule, t derives float, t derives char, like that. Okay. And regarding this assignment, you need to do a little bit of extension. Now consider only void, char, int, and float type specifiers. As specified in C, char and int are to be taken as signed. So we are not insisting to go for say long int, long double, those things. Okay, But if you wish to go, it's fine, no problem. But minimum thing what you have to do, what is mentioned in the assignment. But of course, while you are extending and during that process, your minimum or basic thing which is expected in the assignment should not be missed, or it should not be, say, it should not give the error. For computation of offset and storage mapping of variables, assume the following size in bytes. So it is mentioned here, void undefined, character 1, integer 4, float 8, void star 4, all pointer have the same size. That you know, right? So sometimes we used to define a pointer at the beginning as void star. Then as for the context, we do the typecast. So when we say void star, then the memory is reserved, that 4 bytes size. And when we will say that it is integer star or say float star, then the interpretation for that 4 bytes will be either integer or float. Okay. Now it may also help to support an implicit bool type with a constant 1 and 0. This type may be inferred to a logical expression or for an int expression in logical context. Note that the user cannot define load or store variables of bool type explicitly, hence it is not storable and does not have a size. So that's why in this table you do not see the bool, but you know that bool is required implicitly because you are dealing with the logical expression. So outcome will be either true or false, that you can map to 1 or 0. But we said that, okay, so explicitly bool should not be there. Initializations of array may be skipped. Storage class specifier, enum specifier, type qualifier, and function specifier may be skipped. Function declaration with only parameter type list may be skipped. Hence, void func integer I float d should be supported, while void func int float may not be. Now you see point number 5. The generic use as per the C also suggests or supports this one, that's declaration. But we are suggesting you use this first one, and there is no need for the support of this second one. Why? Very simple. Just today, we started with the example of function declaration. Now, by looking at the function declaration, I was populating the symbol table. So my symbol table was populated with I, with D, and for my example, the return type was void. Return, it was int. Name of the function was func, the identifier. Now, if we go for supporting this one also, then what you need to do, that in the symbol table, type will be entered, float, integer and float will be entered, return type void will be entered, but for integer and float parameter type, corresponding to that, in the identifier or name, there will be a question mark for the variable declaration, because I do not know what is the name of the variable. Okay. So it can be there, that's not a big problem. When later there will be a function definition, I can come back and I can fill, because I know the correspondence. The first parameter is going to be the integer, second will be float. Accordingly, I can do that one. But for this assignment, we are not expecting that one. Statement phase support all statements excluding within for, all level statements, switch in selection statement, all jump statement except return. So external definition phase support function definition and skip external declarations. Address code specification as discussed in the class. So only those specification you please use. Okay. For easy reference, the same is produced here. Every 3 address code uses only up to 3 addresses. What was them? Opcode, argument 1, argument 2, and result. So it is 3 address code, 3 addresses I am dealing with. One address for argument 1, another address for argument 2, and another argument address for result. Opcode will be there. If it is binary, then 3 addresses will be present. If it is unary, then only two addresses will be there, one argument and another result. If for the assignment statement also, you need that 2 addresses, where argument 2 is optional. Now in the address type, so first address is the name as given in the source program, and it will appear in the 3 address code. Then some constants may be there. They may require some storage space or some addresses. And the third kind is the compiler generated temporary. Well aware about this compiler generated temporary. T1, T2 mostly we have used. Now these are the list of the instructions types. I am not going to read this one because we discussed this in the theory class. So binary assignment, unary assignment, copy statement, unconditional jump, then conditional jump, then procedure call. I mentioned the parameters in a particular order, either left to right or right to left. Follow any one particular notation. Okay. Then y call p. P is the name of the function, comma n. N is the number of parameters. Okay. Next, return type, return v. So this is the array, dealing with the array. This is dealing with the pointer and the address. So this we have discussed in the theory class. Now design of the translator. Use the flex and bison specifications. If required, you may correct your specification. Look at this. No need to email me that we need to say correct it. It is mentioned. So if you want, then you can do that. You had developed in assignment 3 and 4 respectively and write semantic actions for translating the subset of tiny c as specified in section 2. Note that many grammar rules of your tiny c parser may not have any action or may just have propagate only actions. Also, some of the lexical tokens may not be used. That is fine. Augment the grammar with the markers and add new grammar rules as needed for the indented semantic actions. Justify your augmentation decisions within comments of the rule. This is required. Otherwise, you will augment something and we are not able to understand why it is augmented, because you know that augmentation, using augmentation, you can give a number of redirections and that is useless. So why shall I do that one? That may incur extra cost in compilation process. So better avoid that. Design the attributes for every grammar symbol, terminal as well as non-terminal. List the attributes against symbols with brief justification in comment on the top of your Bison specification file. Highlight the inherited attributes if any. So in this case, you are not writing only the code, but you are also providing the justification as a comment inside your source code. So that is important. If you miss that one, then there will be a penalty for that. Use symbol table for user defined, including array and pointer variables, temporary variables and functions. Whatever we have discussed, it is asking to do the same thing. Use the symbol table. Here is an example of the symbol table. The same thing that we have discussed in the class. The extra thing that I mentioned is the initial value. When there is an assignment, so I am making that entry in the symbol table during the insertion of the data. So that's why corresponding to a variable or identifier, when there is an assignment, you need to use a separate, say, insert function, which will insert not only the name, type, size of the identifier, but also the value of the identifier. But if value is not present, for example, the variable I or W, Then without value, you use that insert function. So one little modification is required in your insert function with respect to what we have discussed in our theory class, that you need to make a room that if there is an assignment statement during the declaration, then you need to insert that data in the symbol table. And for that purpose, in the symbol table, you have to create one more column with initial value for the storing of the initial value. Okay. So these are the examples. And you are familiar with this one, the symbol table support for the following functions: lookup, gentemp, update, print. Okay. Now for this print, you see there is no typo here. It is not printf. For this print, we are insisting to use your print function that you wrote as assignment 2. Okay. Now the fields and the methods are indicative. You may change their name, functionality, and also add other fields and or methods that you may need. But that indication is somewhat connected or related with the theory class. That's why that particular name is given. So that if you say take your theory class note and then look at this assignment, so you can make a direct correlation between these two. It should be easy to extend the symbol table as further features are supported and more functionality is added. The global symbol table is unique. That is true, that you understand. Every function will have a symbol table of its parameters and automatic variables. This symbol table will be nested in the global symbol table. So the nesting means that in the global symbol table, if I go up here, there is one column, the title is nested table. Here I will give the address or the pointer of the table or pointer to the symbol table corresponding to this function. So that is what is mentioned here. This symbol table will be nested in the global symbol table. Of course, it is assuming that the function prototype declaration or function definition will occur outside of any function. That's why there is an entry in the global symbol table. Now, symbol definitions within blocks are naturally carried in separate symbol tables. Each such table will be nested in the symbol table of the enclosing scope. This will give rise to an implicit stack of symbol tables, global one being the bottommost. The while symbols are proposed during translation. The search for a symbol starts from the topmost table and goes down the stack up to the global table. Now this is interesting. The array to store the 3 address quads. Why you need to store? So you remember that there are 2 ways that you can generate the 3 address quads. Print whenever it appears, or you store that in an array and then print at the end. So based upon that one, or based upon the splitting, so we term that as lazy splitting. So do not split now. You will split once the conversion is complete. That's why you have to have some quad arrays where you will store those. So index of a quad array in the array is the address of the 3 address code. The quad array will have the following fields having usual meaning. Just one. Now argument 1 or argument 2 may be variable or a constant. Result is of course a variable, that is my L value. L value cannot be a constant. Argument 2 may be null based upon whether the operator is say assignment operator or unary operator. For example, if int I equals to 10 and this is written and this is written, this will translate to this. Now this 100, 101, 102 is the index of the quad array. That is what is mentioned here. And this is not something new to you. Always we use that one when we are say printing the 3 address code, it starts with 100. You can start with 0 or 1, but some numbering is required. The quads are represented as, so in the table it will be stored like this. So it's not a big deal, right? So you can even declare one, define one structure variable. An array of structures will give you the quad array, or you can have some other ideas also. We will look forward for your ideas. So the quad array may support the following methods: emit and print. Print is a method to print the quad array in a suitable format. So always it will be printing the string. Emit an overloaded static method to add a newly generated quad of the form result equals to argument 1 or of argument 2, where op usually is a binary operator. Okay. So one example is given here. The above state of the array may be printed like this. Okay, so you can look at this one. Now the fields and the methods are indicative. Now you may change it as per your wish. It's not a problem. You discuss with your partner and then you make it. Some global functions, you are familiar with this: make list, merge, merging of two lists, backpatch. So when you look for one pass and then for the jump statements or conditional statements, using the backpatch, you fill the address. The type check, when you are doing some some operation starting from say arithmetic operation or say assignment operation, then you need to check whether their types are same or not. So we demonstrated one example when we are adding integer and double, then the type conversion, and after the type check or along with the type check, you need the conversion of type from one type to another type. Now you know that when I am moving from lower to higher, then there is no data loss. But if I move from higher to lower, means from double to integer or say to character, then there will be a data loss. I accept that one. So naturally these are indicative again, so you can use your own one. Now finally the assignment and the marking scheme. So you need to write a 3 address code translator based upon the Flex and Bison specification of TinyC. Assume that the input TinyC file is lexically, syntactically, and semantically correct. Of course, it should be, because you passed with Flex and Bison. So if there is some lexical problem, Flex will identify that one. If there is some syntax problem and some semantic, Bison will raise that flag. And if I assume it is correct, okay. So basically, up to assignment 4, the syntactically it is correct. Semantically, I am assuming. The reason is that I am not going to handle error in this particular 3 address code generation. Okay. And also you have to prepare a makefile for the compilation and testing the project. Prepare the test input file. The number is given here. Okay. And you need to upload all of them. Although you uploaded your Flex and Bison specification, but we expect or we may assume that you may change some of your specification to make it work for assignment 5. If you do so, then you need to upload Flex and Bison or your assignment 3 and 4, only this .l and .y and .h part. Okay. And also if there is some data structure, that part, not everything. But if you do not make any changes, then also we expect that you please upload this one. So independently, we can evaluate your assignment 5. So it should not be the case that we will search for your assignment 3 and assignment 4, then integrate with your makefile and then have it. So please upload as a complete package. So prepare a TAR file and upload that one. So this is the marking scheme. So you can read this one. So we divided the total 100 marks into several parts. Okay, so it is very useful because the evaluation will be done based upon this one. So be careful and look at this, and it will also give you some sort of idea that if you miss anything for the implementation, then by looking at this marks or breakup, so you can understand that okay, this part I missed, so I need to add that. Okay, so that's it. Now if you have any question, please let me know.
Yes, sir. I
Yes, Suhas.
Hello.
Do you have any question?
So am I audible?
Yes, yes, you are audible.
Yeah. So, sir, till 8th we have like continuous tests and like classes and assignment along with that. So it won't be possible to do until that time. And then for like at least for 1 week, like most of us are going on like going out of station. So for this assignment, like we effectively have three.
That I said, but you will be having 2 weeks to fix it. So I am assuming you will start on 8th and deadline is 20. In between, so that is how many days? So about 12 days. But you have a partner, so you have 24
Yes, sir.
days,
But like
isn't it? Look, Suhas, the reason is that after 20, so we need to float assignment 6. And as I mentioned that there will be another assignment from compiler theory. Of also, we need to evaluate your assignment after you finish the submission. And there is a deadline for uploading the grades. We are very
so
much restricted.
that I totally understand. Just one request, sir. So current deadline is on till Wednesday 20.
Wednesday 20. Yes.
Yes, sir. Yes, sir. If we, even if we could move till Sunday, that will also be great because currently I'm for like me, I'm having only 3 days, like me and my partner.
Mm-hmm.
So even till Sunday is fine, even if it overlaps with assignment 6.
Mm-hmm.
If we get
Okay.
3 or 4 days.
Okay, I got your point. So, what is the opinion of others? What do you think?
Yes, sir. It would be great if you could keep it till Sunday at least.
Okay, Ashutosh agrees with that one. Now let me
Yes.
open and see. Okay, so whatever may be the situation, but you please note it down. The submission deadline for assignment 6 is November 5th. That we cannot change.
Okay, sir, that is
With
fine.
that, with that, if you find, then so it is fine.
Yes, sir, that does not need to change. That
Okay,
is
very
fine.
good. Okay, so then what I am doing, as you are requesting and Astos is also agreeing with you, so deadline will be then Saturday instead of Wednesday. That is what you are asking. 23.
Yes, sir. Like till Sunday midnight.
Sunday, sir. Sunday till
Sunday midnight.
until Sunday.
Sunday is that an auspicious day for the submission? Just wondering. Okay,
So
then
Sunday is 24th. So 24th midnight will be fine, sir.
okay, then I am making it 24th. But again, please note it down that the submission deadline for assignment 6, the next assignment which will be released on 21st, will be November 5. That we cannot change. Okay. So I am not changing anything in your PDF file here or anywhere else, but it will be in the Moodle submission deadline. Okay. That's why whenever you will look at it, you will see that as if the deadline is on 20th, but actually it will take the submission. Yes, it will also mention that how many more days are remaining. So up to 24th, as you said. Okay. Is that fine?
Thank you, sir. Thanks.
Okay, very much. Thank you very much. Now, I know that some of you have the question, so I will probably send an email to all of you by today regarding the syllabus for class test 2 that is going to happen on the next Thursday. Probably we'll start little late on Thursday so that you will get some time even after your lunch to brush up your concept. Okay. So time is fine. So it will be before 5. So maybe we'll start at 3:30 or 4. Last time we had 2 tests back to back. That's why we started at 2. This time we will start little late. And regarding the syllabus, we will talk and then I will let you know by today. Is that fine? Okay.
Yes.